All right, so we're going to do, this is the second part of R4 that we're doing. And they call this, we'll just put a name on here, they call it special products, okay? So we are special today. We're doing special products. In math, what does a product mean? Multiplication, very good. Okay, so that's multiplication. We talked about this yesterday, but I'm going to do it one more time. And one of our special products is called the FOIL method. We kind of got ahead of ourselves a little bit yesterday. I probably got too excited, and I couldn't wait to get to this. But this is officially today. Remember what that stands for? We talked about this yesterday. First, outside, inside, last. Okay, that's the order that you multiply. You only use FOIL when you're multiplying two what? I said it already today. I even said it today. Binomials, that's right. Okay. So you only use the FOIL method when you're multiplying two binomials together. So for instance, if I had something like this, if I had like ax plus b, and then I had cx plus d. If I was multiplying something like that together, I would use the FOIL method. So let's go through that quickly. We talked about it yesterday, but we kind of did it today. Basically, FOIL method is just distributive property. That's all it is, okay? They just give it a fancy name just because you use it so much, I guess. All right, so what are you going to do? Take the first two, multiply them together, right? Take the outside. Which ones are on the outside? This ax and the d, all right? Take the inside ones. These two are on the inside, and then these two are your last ones right there. Everybody got that? All right, so if I was to multiply these together, you're like, well, Mr. Hamrick, what's the use of doing this? I don't even have any numbers in here. Well, that's all right. It's just so we can learn how to do it. So how would I do this? AX times CX. How would I multiply AX times CX? Well, A times C. What's A times C? It's just AC. And then X times X, X squared. You with me? Let's do the outside. AX times D. Everything's positive, so I'll put a plus here. It's just AXD. Or, why did I do that first? A lot of times we'll do this. We'll put the X at the end, okay? It doesn't matter. It wouldn't make any difference. Plus, what? The inside, right? Yeah, we'll call it BCX. Again, I like to put the X last. All right, and then the last right here, I would go plus BD. Now, then you would look to see if there's any like terms. Now, when we start putting numbers in here, okay, this right here will be something that we add together. This just stays that, this just stays that, and we would add these two together. All right, so let's do one for real. Don't worry about that. That might have confused you more than it helped you. That's all right. Let's do an example. This is example 7. If you look in the book, there's A, B, C, and D. I'm not going to do all of them, but I'll start you off a little bit. Now, these are kind of special. Well, let's see. They're not all special ones. Let's do this one. Write this down. Everybody writing this down? I'll give you 30 seconds to do this problem. Ready? Go. 30 seconds. It's x minus 3 times x plus 3. Figure it out. So multiply these together. Yeah, 15 seconds. I'm just giving you 30 seconds. 5 seconds. It's x minus 3. It's x minus 3, x plus 3. All right. That is correct. So let's watch. I'm going to do it super quick. So first, x times x, which is x squared. The outside, which is positive 3x. The inside, which is minus 3x. The last, which is negative 9. All right? And now you got to add some like terms. Remember I talked about this? Okay, you're going to have to add these together. What happens to these, though? It's 0. All right? Yeah, we could say they cancel out, but technically they add up to 0. Saying canceling out is fine. I just want to make sure you know why they cancel out. And so, Abu said it already, x squared what? Minus 9. And that's how you write the answer. Now, a little bit later on, watch this. They're going to give you this, x squared minus 9, and they're going to ask you to find out what is being multiplied to get x squared minus 9. You hate those? Wow, that's pretty strong. We call that factoring. Why do they call it factoring? Because two things that are multiplied together are called what? Factors. 2 times 3. The 2 and the 3, if they're being multiplied, they're called factors. Okay? We're not doing that today, but we are eventually going to do that. So we're going to start with the answer, and we're going to kind of come up with the question. That's kind of what we're doing. All right? So we'll do that. But notice this thing right here. What happened to the two middle terms? They added up to 0, didn't they? When do you think that would happen? Look at the problem. Is that just random numbers I threw in, or the book threw in? When do you think this will happen when you're not going to get that middle term of x? When what? Look at it. They're both exactly the same except for what? One's negative and one's what? Positive. So when you have a situation like that, you should be able to go directly from this to this, because this is kind of a special multiplication. So when I see that they're the same, I know that the outside and inside are going to add up to 0. So really all I got to do is just do the first, right, and the last. So for instance, what if I gave you x plus 5 times x minus 5? I will give you 5 seconds to figure this out. Ready? Go. 1, 2, 3, 4. Very good. You got it. It's just going to be x squared minus 25. How did I know that? Because when these were exactly the same, except for one was positive, one was negative, the middle terms add up to 0. So all I had to do was the first and the last. Okay? That's perfectly legitimate. Yeah, just to write down the answer to that. Yes. Yep. And I just want you to recognize it. Okay? So let's do another one. X minus 7 times x plus 7. 3 seconds. Do it. X squared minus 49. That's it. Less than 3 seconds. You got it. See? I gave you 30 seconds, right? And you're complaining you didn't have enough time. Now I gave you 3 seconds, and you got it. Okay? That's good, right? Is that progress? It does make me feel good. Yes. Thank you. All right. Let's do a couple other ones. These aren't the same, but yeah, I was going to say something else about that, but I'm not going to. So this is part B to example 7. Now this one, a little bit different. It's not the same thing because one's not positive, one's not negative, right? Okay. But here's the key. That whole thing is being squared. What do you do to something that's being squared? Like if I give you a number 5 and I ask you to square it, what are you doing in your head? You're multiplying it by itself. Exactly. You're multiplying it by itself. So what do you think you're going to do here? You're going to multiply it by itself. That's right. Exactly right. You got it. So squaring something means multiplying it by itself. Now watch. I almost hate to even say this because somebody's going to look at this and say, oh, that's what he said to do. But I'm telling you, don't do this. There is no distributive property for exponents. Do you hear me? You cannot just go x squared plus 2 squared. That is not going to work, right? There is no distributive property for exponents. So what you have to understand is if this is being squared, you have to write it out twice. And now you just do FOIL. Okay? Now, you can't do the thing where you just go x squared and then a 4, right? Because you're going to have a middle term on this one because you don't have one negative and one positive. The middle terms are not going to add up to 0, right? Because everything's positive. Make sense? All right, so you're going to have to do the FOIL. But that's not that big of a deal. We can do that. So first is x squared. The outside is plus what? 2x. That's these two. The inside is also plus 2x. You see it? And then the last is plus 4. Now we got to do a little bit of work. All right? We just got to add like terms. So I've got x squared plus what? 4x, and then you just throw that at the end, plus 4. And that is your answer. You just have to realize when you square something, you got to multiply it by itself. What if I cubed it? We're not going to do one right now, I don't think. We will later on. Then I would have 3 of them there, wouldn't I? That's a little more complicated. We're not going to get into that right now, but I just want you to think ahead. You could still do it if it was cubed. Yeah, you wouldn't get this answer. You get a different answer. But that's for a little bit later, not right now. Let's do one where instead of this is minus or positive, let's do one where it's minus. Okay, so this is part C. So what if I do this? X minus 3 squared. What we say in the math world, we don't just say x minus 3 squared, because that would kind of look like this. Is that going to be the same as this? No. So I don't say x minus 3 squared. What I would say is x minus 3 quantity squared. Or I could say the quantity x minus 3 squared. What that means is the whole x minus 3 is being squared, not just the 3. Make sense? All right, so if I say that, that's what I mean. I mean that thing's in parentheses. If I say x minus 3 quantity squared, that means the x minus 3 is in the parentheses. All right? So what do? I don't distribute the squared through here. I got to write it out. That's right. So when I square something, I have to multiply it by itself. And now you just do FOIL, right? That was the only new part to that. We know how to FOIL. Let's do it. X squared. The outside is minus 3x. The inside is also minus 3x. And then the last, negative times negative, is positive 9. See? Negative 3 times negative 3 is positive 9. I got to finish it up, though, don't I? Got to add my like terms. Don't leave it like this. So I got x squared. What's negative 3 minus 3? It's negative 6, remember? Add a line, change sign, or add the opposite. Okay, so that would be negative 6x. And then what do I do with that 9? Just stick it there on the end. Again, we are going to do something later on where I give you this and I ask you to come up with that. All right? You're just going to have to recognize some things. I'm so tempted to show you how to do that, but I'm not going to. We'll wait till we get there. All right? Part D is just a plain old FOIL method. I'm not even going to do that one. And really, part E is as well. And yeah, we're starting to get close to running short on time. So I'll let you look at D and E in the book. It's just normal everyday FOIL method. It's nothing special. These are kind of special ones right here. All right? And do you remember that? Let's see. This one right here. X minus 3, x plus 3. Let's do that one again. Now, I already talked about it. Let's write it down. My goodness, let's just do it. X minus 3, x plus 3. And what do we say this was equal to? Again, we should be able to do this. This is that one we should be able to do in 3 seconds. X squared minus 9. Now, the reason I'm doing this again is I want to show you something. Remember I said they're eventually going to give you this, and you got to come up with that. Whoops. There goes my crazy pen again. All right. Remember that? Here's something that's really important to know. We name this kind of answer. We call this, write this down, we call this the difference of 2 squares. Why is it called a difference? Why would I name it difference? Look at this thing right here. Why would I name that difference? What's difference in a math problem? Subtraction. So do I have a minus here? Do I have a subtraction? Yeah, that's why we call it difference. Of 2 squares. Well, this is pretty easy. I'm squaring something, aren't I? What am I squaring right here? The x. Now, look at this one, though. What am I squaring to get 9? Squaring a 3, aren't I? Okay, so this is considered to be a difference of 2 squares. If you recognize this, you should be able to come back to the answer. So this is a difference of 2 squares. What about this? X squared minus, is that a difference of 2 squares? It's not, because I'm not squaring a number to get to 7. Well, technically I could square root of 7, but as far as whole numbers go, No, I'm not squaring anything to get 7. So this is not a difference of 2 squares. What about this? Is that a difference of 2 squares? Yes, it is. There's the difference. And then are you squaring something here? Yeah, you're squaring an x. Are you squaring something to get 16? 4, right. 4 squared is 16. Is this a difference of 2 squares? Yeah, because I'm squaring an x, I'm squaring a 5, there's the difference. Is this a difference of 2 squares? Think. Why? That's right, because you got a plus, all right? It's got to be a minus, so this you cannot factor. That's what we call factoring, okay? You can't do that. So what if you had this, though? What if you had x squared minus 49? And I asked you, what 2 things are being multiplied to get to this? You should be able to do that. Look at here. How did you get from here to here? Well, you put 2 parentheses. You're going to put an x and an x. One's going to be what? Right, one's going to be minus, one's going to be plus. I always like to put the plus first. It doesn't make any difference. Now, what goes here? How did you know what goes there? Yeah, they're the same, but they have to multiply be 9. So basically, you're just taking the square root of 9, right? Or what times itself? What's being squared to give you 9? A 3 is. What's being squared to give you 49? A 7. So I could put a 7 right there and there. Okay? They're not going to ask you to factor it, but they do want you to understand what it means to be a difference of 2 squares. We'll do that later. We'll do that more later. I don't want to get too confused. How much time we got? 5 minutes. Trying to figure out. I think we've done enough. Example 8, I'm going to skip example 8 because when I taught it, I think I gave you enough examples to figure that out. Let's do this. I mentioned it, okay? I kind of alluded to it a little bit, but we didn't do it. What if I asked you to do this? That's exactly right. That's good. And that's the key to this problem, okay, is that you write it 3 times. So I've got an x plus 2 times x plus 2 times another x plus 2. Everybody got that? Okay, now, here's what I would do to solve this. Everybody watching? I know I've been going a long time. I know it's warm in here. I know the bell's about to ring, but I want you to hang on just for a couple seconds. Well, minutes. What I'm doing right here is this. I'm not doing all 3 at the same time. I'm pairing them up, okay? So I'm going to leave this out here. And then I'm going to figure out what all this stuff is right there. And you should be able to do that. That's just a binomial, right? Binomial times binomial. It's FOIL method. Let's do the FOIL method in our head. What's that going to be? X times x, which is x squared. Now let's do the outside and inside at the same time. The outside is going to be 2x. The inside is going to be what? 2x. Add those up, you get 4x. See? You can do that in your head, can't you? Let's do the last. 2 times 2 plus 4. Are we done? No. Now we can distribute just like we did earlier. So let's take that x and distribute it through here. I'm not going to draw the arrows this time. I'm just going to do it. So it's x times x squared, which is x cubed, x times 4x, which is 4x squared, and then x times 4, which is just plus 4x. All right, let's do the 2 now. Let's distribute the 2 through this. So what is that going to be? Plus 2x squared, that's good, plus what? 2 times 4 is 8x, and then the last one, plus 8. We're not done. What do we have to do? Add like terms. Any other x cubes? Nope. Any x squared? Yep. 4x squared plus 2x squared is 6x squared. 4x plus 8x plus 12x plus 8. Wow. So this seemingly innocent little problem turned into that big old long answer right there. Okay? But that's how you do that kind of stuff. We okay with that? All right. I don't have time to do any more. And I think the other examples they give, I think the other examples they give, we've already covered, so I think we're good. So here's your homework. It's pages 48 and 49. And 47. So you're just kind of taking up where you left off on the last homework. And we're going to 87, but again, we're only doing the odds. Okay? 47 to 87, just the odds. Everybody good? All right.